landmass. Give me a second.
What is? Yeah.
It is over Warland, if that helps. I don't actually know where I'm looking at.
So it's Planet Warland.
No, that's a city. Give me a break.
Okay, so we have a city covering a quarter of the Earth's surface. If that's the curve.
No, directly above. There, I'm sending a screenshot.
He doesn't get it.
No.
Oh, Sara's just posted a jiggly moon, so the moon jiggles.
Listen, the time-lapse footage of the moon that I just posted is
Sara, that's not a spinning ball, though. What's going on there? Because that's not a spinning ball.
Right, listen,
that's like
forget spinning ball for a second. You can see slightly more of the left side of it and slightly more of the right side of it to the point that it proves it's a ball.
No, you just said it's not a spinning ball, because that's not showing us the spinning ball. You've just done a little jiggle moon.
It does show that it is a spinning ball, but our angle is always at the one side of it.
Why is it not spinning all the way around?
Wait, Clipcord, get the clip.
But you're not letting me answer.
Yeah, why is it not spinning around?
We spin too, and we're spinning at the similar rate.
What evidence do you have that we're spinning? What evidence do you have that we're spinning?
Centrifugal force keeping you stuck to the Earth, or you to fling off.
Well, that's not evidence of the Earth spinning. What are you talking about?
We just see galaxies and planets moving, and us in relation.
Okay, yeah. So we just see the stars moving. That's them moving. What evidence do you have that you are spinning?
It's the most simplest explanation. Occam's razor.
So it's not actually based on evidence. It's just a thought.
No, you're having all sorts than I am.
Let's say this then. Who's measured it? Who's measured that spin of the ground?
Literally everyone.
Everyone.
Name one person.
One. Just name one.
Me.
Now, how did you do that?
You guys, come on, man. You're just like.
Yeah. Okay, so you didn't, Sarah. Okay.
Even if you had all of the evidence in front of you, which you do,
you don't have any. What evidence would that be?
You don't want the truth. You just want to have a conspiracy. Your lives would be empty without a conspiracy. Your lives would be empty.
They're so rude. They're asking for evidence. They're so rude. They're asking for evidence.
That's all right. Let's try Zach. Zach, you were trying to do something about U2 spy plane.
I'm not trying to. I'm just trying to understand it, because I'm just confused. I'm just out here. I'm confused.
Real quick about Zach. Zach, the image that you posted, you're coming to a conclusion that it is the curve of the Earth, but you're discarding other variables that might cause the image to look the way it looks.
What variables would that be, please?
Okay, so in the same video that you observe with that convexity that you see in the image, you also
images.
Listen, bro. Hello. In same footage that you can observe this convexity, you can also observe concavity, the image going from convex to concave, and also completely horizontal. So that will indicate to you that is an optical thing that is happening, not a physical thing on the surface of the Earth.
So you're saying that it looks curved because of the camera? Is that what you're saying?
Bro, just check the cameras. All cameras have all lenses have distortion, and that is the case.
Why is the Earth distorted in the camera then? And why, when I take a photo, does it come out as a square image? I understand if it's a wide-angle lens, but this isn't.
That's why, because you can take a photo. I mean, why?
I can take a photo.
Okay, so
in both of the images, lens distortion is disproven because there are objects in the corner of the images.
You're saying that the only variable that is possible is that this is actually the curvature of the Earth. Now, have you gone to the Earth and checked if that curvature is actually there, and it is not another variable?
That's the money for that.
You need money to measure the Earth?
You say that like I can just get in a car and go up to 35,000 feet.
No, you can just go across to a body of water and look across
No,
it.
I'm not talking about calculations from Salt Lake. I'm talking about images here from a U-2 spy plane flying at 70,000 feet where it shows curvature, right? And you can say it's a camera lens thing, but there are images, there are objects in the corner of those images that aren't distorted. So why would
it depicts planet California?
That's not what I said. I said directly over California. I said over California.
Hold on a second. Hold on a second. We've been looking at these types of images.
See less than 1% of the surface of the Earth.
Yeah.
Okay, that's cool. All right, so I'll just get to my final point here. If you live on the equator, then during both equinoxes, you will physically observe the sun rising and setting perpendicular to the ground. And I know you guys believe that when the sun rises and sets, it's actually just moving closer or further away.
What do you mean
But based on that
to the ground? Hold on. What do you mean by that?
Like straight up and down. It's not at an angle to the ground. It's
not exactly straight
like
up and down.
It is. If you're on the equator.
It's not. We got
during the equator.
No, it's not. You're saying that. We've tested this shit, dude.
Again, if you live on the equator, during the equinoxes, you see it go 90 degrees.
Equator, dude. We've tested this at the equator. You're just talking ass.
Yes, I agree.
Yeah,
there are videos of
it, dude. And like, listen, if the sun was directly overhead at the equator on the equinox, whatever you had some pole or something, and it was plumb, it wouldn't cast a shadow, right?
Correct. Yeah.
Okay, but we recorded it casting a shadow. So, thank you.
No, I'm not talking about when it's directly overhead. I'm talking about when it is rising and setting.
Well, it can't be rising and setting Earth on the horizon.
When it is rising and setting, it moves 90 degrees up and down from the ground.
And what I'm telling you, it's not exactly 90.
It is in those locations at that time.
How do you know that?
There are tons of videos. Like, people record this all the time. You can see the sun moving straight up and down.
Okay, but it's not. Listen, that is a subjective evaluation. Okay?
No, it's
the way you can test it objectively is by seeing if something casts a shadow. Okay? And if it doesn't cast a shadow, it is 90. And if it does, it's not 90.
Again, you're talking about when the sun is overhead in midday. I'm talking about when it is rising or setting. It's moving closer to the ground when it's setting. And that moving closer to the ground is exactly a straight line up and down.
It's not physically moving
closer no angle
to the ground, dude.
Right, it's due to perspective.
Okay, fine. What is it perpendicular to?
The ground.
Visually?
Yes, visually.
Okay, so visually the sun appears to come straight down. Is that what you're saying?
Yes.
Okay. Just for the sake of argument, I'll say it's 90 degrees. Okay, go ahead.
Great. And we have videos that prove this. So my point is...
No, you don't.
Yeah, we do. We have tons of them.
Okay, give me... how did they measure it? How did they measure its perpendicularity?
You just look at the video.
You just look at it? It's not a measurement. Looking at it isn't a measurement.
Let me finish. You look at the video, and you put your protractor up on the screen to follow the sun's path as it moves to the ground. And if the sun's path moves directly vertical to the ground, then that means it's falling at a 90-degree angle to the ground.
Okay.
Like, you can measure it on your TV screen.
Okay, you can measure it? Okay, in what, a 2-degree field of view?
Yeah, that's all you need. It's 2 degrees.
Oh, dude, you
2 dimensions. 2 dimensions.
Is this done with a solar filter or not a solar filter?
Without.
Oh, without. So you think that you can measure the direction of the sun with in what level of precision? 1 degree, 2 degrees, half a degree? You know no one's ever done this, and you're just making this shit up. But that's okay. Let's continue.
No, actually, there are tons of videos out there where people put two parallel lines.
Post one. You're not doing anything else until you post one. You're not doing anything else until you post one in the chat. Because now you want to say it 3 times that there's tons of videos. I was just going to ignore that, but now I want the evidence. Post it, please. You have tons, dude. Tons, lots to pick from.
Yeah,
go ahead.
I'm going to pull one right now. So my point is, if the sun does move straight up and down at those times and on the equator, then that means.
Okay, you're muted. I said you're not doing anything else until you post your evidence. I wasn't even gonna go there, but you want to keep asserting what you know is fucking false. Well, not false, it's baseless. I didn't even get into the fact that there is no fucking equator in the first place from which to do a measurement. So how long should I wait to get him to concede that he don't have that? A minute, 2 minutes?
This guy will never tie it to a conclusion. It's like he's afraid of his claim. Just one of those guys.
Oh, I'm kind of unfamiliar with him. All I know is that when I see him in VC, sometimes I'll have the YouTube stream, but it'll be muted, and I'll just click that tab and I'll look and see who's talking. And whenever he's in here, I just see that he's in here for a long fucking time, which tells me that like it's just like deflection, all the nonsense. Like you just said, he'll never get to his point.
Yep.
Like,
just go on.
I figured that out by just seeing his name flashing.
Well, my point is very simple, really. The sun does not move in a curved path through the sky. That's my point.
Why? Because it moves straight up and down?
That's correct.
Okay. I'm going to make a dumbass Glober argument. Can the arc of that circle be so large you can't perceive its curve?
Yeah, it could be. Is that your claim?
Yeah. So you just flushed your own fucking claim, dude.
So a circle can be so large that it can look
flat.
Now
you can admit that you lied, that you actually don't have any of those videos. Now you can admit it. Now that I cooked your whole fucking point.
Oh no, I was in the process of looking, but you guys said I can never make a point, so I came back to make my point.
Okay, so your point, well, we've heard it before, okay? Just to let you know, you didn't invent it. We've heard it before, and it's the same thing. The arc of the circle would be a 25,000 mile circle, right? Equator. If all your premises are true, that circle around the North Pole, that circle would be a 25,000 mile circle. And the arc that you see in the sky would be so small, it would not look curved, it would look straight. Because you're only looking at a very small portion of the arc, like 1 degree of the arc.
Cool. So you agree then, if a circle is large enough, then a tiny thing on its surface is going to see what appears to be flatness. Correct?
Okay, this is different because you see, this is what you guys also do. You guys are conflicting. Looking at a circle from edge on is different than being on top of a sphere and looking at across its surface. It's different. See, there's the body of the circle, like a sphere. Its whole body creates a circle, but you're not looking at it from that point of view. You're looking at it from on top of its surface, and you're looking across it. Your vision is a cone, not a circle. And it's like a truncated cone, right? So if you had like a cone of vision that's stretched out, extended from your body, part of that cone is cut off, right? The center of your cone would be your eye, the direction you're looking. Right? But the cone of vision is the circle that bounds you on a globe, right? So it would be like you're on the center of at the apex of a cone, and you're looking at the bottom of the cone, the edge. But if it would be a severely flattened cone, right? See, this is what disappoints me, is that you've heard these explanations because these aren't your ideas. They come from externally from websites or anti-flat earthers or whatever. And you've never really thought about if what they're saying is applicable. They'll show some person zooming in on a circle, and you think, yeah, man, you can zoom in on a circle and it'll look like a line. When you're standing on the surface of the sphere, you're not zooming in on a circle. And the circle of your vision is small, right? So just think about it. If I'm standing on a sphere and I can see 3 miles, the curve of that circle is small, and that's the circle you're looking at.
Yeah, that's just evidence for why we live on a globe, but it would appear flat.
Someone wasn't paying attention.
Yeah, exactly, bro. Yeah.
I literally just posted photos showing how, like, as you get higher up and you produce tangent lines, like you can see an arc that correlates to your thing. I tried doing it at 2 meters, and it just kept calling the tangent lines horizontal. So you're saying, oh, how can you have a horizon on a globe? Well, I just modeled one, and it's calling the tangent lines, saying, cannot resolve.
Okay, you fucked up. So here's the problem with what you did, Cosmos. This is an orthographic view, external. This doesn't tell me what things would look like from your perspective, does it?
It's a 3D model.
Yeah, it's orthographic, right? So railroad tracks, if you drew them on here orthographically, they'd run parallel forever, and they would never intersect. But that's not what they look like, is it?
No. So
yeah, they look like they converge into the distance, right?
No, you're showing a horizontal.
Don't address what I said and talk about some other shit I didn't talk about. Yeah, do that. Look, railroad tracks. Draw them orthographically like you did, a blueprint view, external. Okay, parallel lines. That's what you'd have to draw them as. But if you drew them in perspective view and looked at them, they would converge into the distance. And you're saying, look what I drew orthographically. I'm going to tell you what things look like. Sorry, it don't work that way. If you want to tell us what things look like, then you have to draw or in the right viewpoint.
Yeah, right. Can I respond?
Yeah.
Because, yeah, orthographically, you wouldn't see recession of, say, lines over distance and convergence. Like, I know this, I use CAD. What I'm saying is horizontally, I'm showing how, because it's fine horizontally, because it's not like the curve is receding over distance. It's just showing that you see a visible arc the higher up you go. And I can just take a screenshot on my laptop here that at 100,000 feet, it's showing that you should be able to see a curve. There's no problem.
Okay, so you tell me this. Does the horizon dip in the glow model?
Does the horizon dip?
Yes, from eye level. As higher you go, like the higher up you go, the horizon dips, right?
On which axis? Horizontally?
Yeah,
the vertical
eye level.
Yeah, it becomes more. Yeah, it becomes more pronounced the higher up you go.
We're talking about dip angle, dude. The dip angle. The horizon should dip down some number of degrees depending on your elevation. So at 128,000 feet, the dip angle should be 6 degrees.
Okay, yeah.
That means from eye level, it should be dipped down 6 degrees, right?
If you have the maths there, then sure.
Okay. I'll post in a second. Can any part of the horizon appear higher or lower than any other part of the horizon if it has the same dip angle?
If it has the same dip angle, no. Like all throughout.
Okay, then you don't see curve from 100,000 feet. Sorry.
No, you do, because the dip angle does change.
What's curving then?
The Earth.
Sorry,
how could it be curving down if the entire Earth, which would be the edge of the Earth, which is the horizon, right, has the same dip angle at every point on it?
No, No, I'm saying it doesn't. It doesn't at every elevation.
It doesn't.
Sorry, hold on.
That's not what I said, man.
Sorry to interrupt.
Yeah.
Sorry to interrupt. My friend, make the same measurement at the same altitude, but turn in 4 different directions. So you're literally making 4 measurements, dip angle measurements to the horizon as you turn around. Are they the same angle or are they different?
If you turn around, yeah, they should be the same dip angle. If you've kept the same plane of where you're looking with respect to the horizon.
Cool. So where do you see curve then?
Well, I assume you'd start to see curve, like, I don't know, somewhere in the high tens of thousands of feet, like
you just don't listen, do
curve.
Like, you're not really. I don't know if you're not comprehending or you're not listening, dude. What would be curving? How can it look? You take a photograph, right? So it's a photograph. It's a projection onto a plane, right?
Yeah.
You just said if I look in 4 different directions, it's the same dip angle. So if I just rotate, right, no part of the horizon can appear lower than any other part of the horizon. That's a line.
At ground level. At ground level.
No, at elevation.
Yeah.
Yeah, I'm saying you see
6 degree dip in the horizon at altitude. You turn around 4 times and it's the same 6 degree dip from the horizon at altitude.
It's like looking at it this way: draw a ring around you, right?
Yeah.
The ring is still consistent despite you seeing an arc.
It's a circle. No point being higher or lower than the other.
Right. This is the problem. This is the problem if you say it's a
where's
flat
the curve, dude? That's the problem. You're not measuring curve when you turn around and take the 4 measurements. It's still 6 degrees downwards dip angle, right? So you're not measuring curve. You're just measuring a circle around you. That would be, the limit of vision, your horizon. That's all you're measuring.
Right. Look at the distance you would observe to the ground, right? It's going to be huge. At high elevation, it's going to be huge. So it's not just taking an arc because
based on what calculation?
He's switching his argument. He's moving the goalpost to some fucking distance argument.
Based on the size of the Earth. If you're taking a line, right, which comes...
No, it's based on the limitation of the optic. How far you can see. You're saying the Earth curve is going to stop how far you can see, apparently. We haven't measured that. We've measured it 4 times. It's 6 degree dip.
We have. The only inference you can draw from the evidence.
Sorry, you haven't. You took us up into an aeroplane. Indio's pointed out about the dip angle. You agreed, but we don't measure any curvature of the dip angle. There's no curvature here, left to right. Is there? No points higher or lower, is it?
You just keep saying that. You see...
Sorry, you agreed. You must agree to the consequence of your argument.
You literally see, right, the continents themselves curving.
That's got fuck all to do with the horizon.
Curving continents on a flat plane.
Sorry, what curving continents? You haven't measured any yet. The horizon isn't curving as we just measured 4 times.
You can literally see them from high altitude.
See, not measure.
What is a measurement based on? What do you do when you measure something?
At the moment, we're measuring the dip of the horizon from eye level, 6 degrees.
What do you do when you measure something? What's required to measure something?
Dude, stop waffling. Just agree the consequences of what we've just pointed out.
Agree.
We do not measure any part of the horizon being higher or lower when we obviously turn around 360 degrees. It's a circle around us, not curving downwards.
At ground level.
No, at altitude. We measured the dip in the horizon at 6 degrees. Are you not paying attention? You jumped into the conversation and I pointed out you weren't paying attention, and now you're definitely not paying attention. We're not talking about being on the ground 3rd time. We're up in the sky measuring the dip of the horizon at 6 degrees, 360 degrees around the observer, not measuring any part being higher or lower. Are you dumb?
No, because if you took the same plane of reference, the dip angle
plane of
would be larger.
reference. Sorry, what are you waffling on about now? We're just measuring the horizon. Can you concede we're not measuring any curvature yet?
No, I'm not conceding. At the ground. Yeah, that's like the level of maturity and argumentation on here.
Are we on the ground in an airplane?
No, you're up in the sky.
Do we measure the dip of the horizon in an airplane?
No, it's barely registerable.
At 6 degrees at the calculated height? You agreed to it earlier. Do you want Indio to give you the math?
Stupid.
Right. Yeah, you can show me the math, and we can see how much it would differ.
Up. Brother, I already did. Just scroll. I'll just post it again, so you don't have to scroll up. I'll scroll up for you. The bottom, where it says dip, 6 degrees, 19 minutes, and 28 seconds. Or 6.32 if you're doing the decimal.
Can you add the link?
Oh, yeah. So this would be from 128,000 feet. The reason I'm using that because that's the Felix Baumgartner jump. That's how high he was when he jumped out of his balloon. In his balloon jump, the horizon looks flat, and he jumps out of an airplane, or he jumps out of his balloon, and the thing is that the horizon is at the same dip the same angle when he's at 120,000 feet as he is on the ground at 10 feet. Well, he's not on the ground. It's like right when he takes off. So that there was no horizon dip that was experienced by Felix Baumgartner.
Is there any way to visualize the Earth compared to the height Felix Baumgartner jumped at?
What's the distance to the horizon at?
How can you measure that? I mean, how do you measure the distance to the horizon?
Well, don't you guys quote it all the time? I'll just put it in the calcs.
Well, the distance in the graphic I posted, the distance to the horizon's in that. So the input's 128,000 feet. The calculation, you can't do any of these calculations without knowing the horizon distance or calculating the horizon distance.
Right. So 6 feet height, distance to the horizon, not accounting for like atmospheric conditions, would be
3 miles.
What?
Yeah, from 6 feet, it's supposed to be 3 miles.
Oh! I thought you said 63.
No, the formula for the horizon distance is 1.22 times the square root of the observer's height in feet.
Why did we give a specific latitude? Are you just putting that in?
It doesn't, because the guy who made this is an anti-flat earthers website. This isn't a flat earthers website. Because they say the Earth is an oblate spheroid, he put that in so you can calculate the curvature at that spot.
Right.
The difference is so minuscule that it doesn't matter for anything we're talking about.
At 6 feet height, objects 3 miles, though I assume it's just referring to, say, some reference of an object, but I put 3 miles for the sake of argument. Dip 0.0434 degrees.
We're not talking about underground. We're talking about at the elevation, which you said you can see curvature.
Yeah, that's literally why I was saying the dip angle increases as you go higher.
Great. Awesome. Go ahead, Jedi.
No, I'm glad he finally got that part, that we are actually talking about being at 20,000 feet or whatever you claimed. Yeah, we're not on the floor. It's the dip angle. Yeah, it exists and will increase, obviously, as the eye of the observer increases above the surface. Good. Please carry on, Indio. Is that fuck?
Yeah, that's literally what I was saying. Was I not saying that?
Yeah, okay, so we're pointing out, measuring the dip dip angle to the horizon from 4 observations, i.e., you turn round.
Yeah, so if you have a photograph of like the horizon at a high elevation, right? And you can look at that photograph, and there's points, like all the points on the horizon are supposed to have the same dip angle from eye level. All the points, every single one, because they're all supposed to be equidistant, right?
Yeah.
Okay, so if they're equidistant and they have the same dip angle, how can they appear higher or lower in the image just because they're at the side of the frame?
What do you mean?
Okay, you take a photograph, it's a rectangle. Every part on the edge of the horizon is the same distance from the camera, and it has the same dip angle. How can it appear different in the frame, like where it's positioned?
Because you go higher up from the rectangle. Right, and you're saying take it at different points.
The rectangle I'm talking about is the photograph.
You draw an abstract ring, right? And you'd say, if I'm almost level with the ring, if I'm like a bacteria on the ring, it's going to seem like it's completely horizontal. Like I look in any direction, and nothing seems to arc.
Right, it'll be a circle around you, and as Jedi said, that's not Earth curve.
Right. I go higher up.
It's over, man. Like checkmate. Done.
I go higher up. Suddenly, the horizon seems to start curving. Right, and you can say,
whoa. What? Curving? No, if we're going to turn around, we're just going to measure that same dip angle 360 degrees around us. The curving is just let's call it an abstract of the photograph, where I don't know, the peripherals on the side, the circle that's around you appears to go downwards in the photograph. But if you were to look at that directly and measure the dip angle, it will be the same as you measured before, measuring no point being higher or lower than the other. There is no curve. Stop saying go higher and see curve. You've gone high enough, it's not curving.
Your own calculator, the calculator you cited literally says you're wrong.
Sorry, that's your calculator working on the presupposition that the Earth is a sphere, and the horizon that we're actually looking at is physical.
Right. Why did you give me it if it literally complies with
what it would be? You'd ask to make a prediction.
Clown. It's called an internal critique.
Yeah, Mike, it's completely
internally
consistent.
critiquing
you haven't refuted anything
without accepting it. I'm internally critiquing your worldview without accepting it.
And it's completely consistent. But you linked me a calculator. The calculator
isn't consistent with your claim. It isn't consistent with your claim that you're going to see Earth curve from 100,000 feet. That's for fucking sure.
It would. It would.
We didn't measure it 6 degree dip, 6 degree dip, 6 degree dip, 6 degree dip as we turn around. Let's say we face north,
the horizon,
east, south,
1,000 miles away, 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 and you think it's going to look different in the photograph, one part than the other part. You're not well, dude.
What did you measure,
bro? Do you understand when you? A high altitude balloon, you take a photograph of the Earth, you see the horizon.
Yep.
If I take any pixel on the horizon, which pixel is the furthest away?
The furthest away.
Don't interrupt. Which pixel is the furthest away?
Which pixel's the furthest away?
Yeah, the part of the Earth, right? Which pixel represents a part of the Earth that's the furthest away?
It's a circle. It's a radius. So every single pixel that's seemingly displaying the horizon would be the same distance away.
Okay, how can it appear higher or lower in the photograph?
How can it? Are you taking it as a level shot, a completely level shot to a tangent?
How can it appear higher or lower than a photograph? So if the camera's not level, the pixel in the horizon's closer or further? Is that what you're saying? I can move the horizon by tilting the camera?
you mean moving the dip angle by tilting the camera up or down.
That's great, but no matter what way I move, tilt, or move the camera, the dip angle is still the same, right?
No. Oh, along a horizontal plane, right? The dip angle should remain consistent.
I'm almost at a loss for words, dude. I almost can't take no more of this shit.
What I'm saying completely complies with the maths, and yours is just an incoherent garble.
Dude. No, dude. Listen, the math is fine. Okay? There's a one dip angle. There's one distance to the horizon. If you take a photograph, you're not taking a photograph of curvature. You're taking a photograph of the bounding circle, the limit of your vision that's in a circle all the way around you. It is not a freaking arc, a vertical arc.
Oh,
it's not a McDonald's freaking emblem out there, dude.
By the way, can I give you an olive branch? Because we can go on to discuss the inference from this. I could say you could say the fact you are seeing a curve does not in itself prove the Earth is a globe, and I could say that is absolutely true. The other part of the footage absolutely proves it's a globe.
What footage? I didn't see you post any footage.
Okay, I'll just post the link. I'm gonna have to bring it up again.
Footage of what?
It's a high altitude rocket launch.
Okay, it's the horizon curving in this one.
Right, there you go. So you can see anyway the dip angle changes because the camera's
the horizon works, dude. I'm well familiar with this video. You guys think the horizon doesn't work because you guys don't analyze shit closely enough. Just because he says it's a rectilinear camera doesn't mean there's no distortion. Okay, if you watch his test in the beginning of the video, you can see distortion at the freaking edges. Okay, there is distortion in this video.
At the edges, that's where you get the most barrel distortion. Like, that's fine.
Dude, there's distortion all through this video,
most of the frame.
And there's a good reason for it. Okay, they know this in design of high altitude aerial cameras because they have to be sealed, and the camera itself has to be calibrated for low pressure, low temperature, because the refractive power of the lens increases. Right? Because there's a vacuum. Right? Listen, why you interrupt me? So at sea level, air has one refractive index. At low pressure, right? At high altitude, such as 120,000 feet, or I think this is 93 miles. So at 93 miles, it has a lower refractive index. So that means when the light hits the lens, it does not refract the same way, and it causes what's called Petzval curvature. Now, this is all in the literature. It's all in the academic literature. Okay?
You realize you can have a hermetically sealed.
And you want to guess what I said at all because you fucking didn't even listen to the goddamn word I said.
No, you can have a hermetically sealed camera where it doesn't. It's minimal.
Is this hermetically sealed? And how does he control it for temperature?
Hold on, you can see the lens. You can see the reflection of the lens off the glass. So you're assuming
doesn't mean it's hermetically sealed.
Yeah, it's not good. They're not going to put the camera at vacuum,
and he has to control for temperature because it's negative 53 degrees Celsius.
I think it actually starts increasing in the stratosphere, the temperature, because like when you're in the stratosphere, there's less air to transfer heat to, so you're actually
I'll just post the citation, dude. It's no even. You can give me your opinion. I don't give a shit because the engineering of the field takes into account all these factors, and this guy didn't.
I mean, none of you are engineers. I'm an engineer by trade. So, like,
sanitation engineer.
Sanitation engineer. No.
Yeah, you clean toilets.
Is that your claim?
He's taking a piss, dude. What the fuck?
Well, if you just say I'm an engineer, that could mean anything. I'm a network engineer. Whoopie-doo.
Okay, okay. I'm a mechanical engineer in the energy industry. Like, does that help?
You must be the person to talk about optics, then.
As if we are like appealing to authority.
You realize there's a much bigger problem here.
What for you? You haven't measured curvature yet. Yeah.
The footage, right, completely complies with a globe based on what you'd expect to see, regardless of any warped curve.
What would you expect to see?
It doesn't comply with any flat Earth. Sorry,
you're just saying that, dude.
You expect to see only a part of the Earth.
How do you know what you would expect to see?
Induction, deduction.
Yeah, so
give us the syllogism.
Yeah.
What the
syllogism you would expect to see? I'm asking you how you would know what you would expect to see, being as you've never experienced it.
I've never experienced being on the Earth at a certain height.
No, at that altitude, dumb fuck. So I'm asking you how you would know what you would expect to see. Have you got some math or something that you're using?
Because
what you think you should see?
Yeah, physical law's consistent.
No, oh God's sake, this child is fucking tolerable. How do you know what you would expect to see?
Because physical laws are consistent, so I expect reality.
So we're talking about how much curvature should you see from this altitude in the horizon again?
That I assume you'd see just like a few degrees of curvature. You're not that high up in reference.
You've got no standard. You've got no standard of comparison or measure.
Okay. Let's look at the source you posted.
You posted fuck all.
Angular size. Let's go. For fuck's sake, it's American feet. What's 90 kilometers in feet? Oh, in fact, it says in the thing. 200.
Computer right next to me. I can fucking translate it from one to the other. God, life's so hard.
Right, 293,000 feet. I don't really like this object distance because it's not exactly. Can I just not put something in the object distance because I'm purely looking at the horizon here? And image width, field of what's a standard field of view for a rectilinear camera?
You should know. This is your evidence, right?
We're trying to go through it.
Yeah, but it's your evidence.
Well, okay.
No, your evidence, not his evidence. He's trying to find holes in your evidence.
We're just slowing it down because I know everyone has internet access, so we're just trying to go through it. Okay. Fuck's sake! I've got the lens focal length. Does nobody just have this information so we can just speed it up?
Field of view varies by the focal length of the lens.
Yeah, it does say the focal length. 4.35 millimeters.
It's a terrible field of view. Well, actually, a good field of view, but terrible for everything else.
Yeah, I mean, I suppose it's trying to minimize distortion.
No, most rectilinear lenses for say like a GoPro are like 7 millimeters in focal length.
Does nobody just have the figure that they can?
It varies, like I said, it varies from lens to lens. You have to know what the lens is.
Yeah, but we just take but we can just take a ballpark figure, can't we?
Most use wide angle lenses, which means they do more than 90 degrees.
Well, I mean, what does it look like in the footage? It's not 90 degrees. Oh wait, no, sorry. I'm bullshitting. Yeah, it's. Should I just say 90 degrees?
Yeah, 90 degrees is like the minimum for most lenses. After 90 degrees, you're starting to get into wide angle lenses.
So, right. So I'll say for the sake of argument, I'll make it low. I'll make it 80 degrees, right? For the sake of argument, just so it's like worst case scenario. So angular size. No, it's not right. I just put an object 1,000 miles away so it would give me something, but because they're looking above the Arizona desert, so I just say, well, there's something 1,000 miles away. It would say 3.1787 degrees, angular size. Yeah. Wait, what's it measuring when it says dip exactly? No, sorry, tilt.
Of angle from eye level
the tilt,
to the horizon.
The tilt.
Oh, sorry,
I misspoke. What's the tilt measuring? Does it have a table of?